Okay, so we're in our functions section in Python, and functions are basically like one of the most useful things in any programming languages. And we've kind of like looked at the basic structure. We looked at the basic structure above in terms of how to define a function, the name of a function, and what it might return back, a doc string along with a function, and then, in theory, some body of code. And finally, we may or may not return a value from the function. And then, and after that, let's calling our function. So let's just try one out of the Python documentation, and we'll do a first version of it, and then afterwards we're going to elaborate a little bit and improve on it. So I'm just going to drag over the documentation. I've already got it selected. You can go here and select it without the dots. So I'm going to select this function, and we're going to paste it into our code, and we're going to just try and run a couple of parts of it. In fact, I'm going to select all of the function and paste stuff into the code here. So we're going to write a Fibonacci series up to n. Now let's remove this first bit because we don't need it, and the reason why we don't need it is we've got our doc string. And let's just remind us, we've got a function. We see that we've got a block of code inside of the function, which is indicated by the equal 4 white spaces for each one. If we moved our indentation back one, so something like this, it's out of sync and it throws errors everywhere. So our function format looks like this. We see the colon at the end of the function as well, and that means that we move into, so the colon's over here, and that means that we move into our block of code. So what else do? We can hover over the function because we're able to call a function at the end, and we see the doc string print a Fibonacci series up to n. That's exactly what we see up here, so it's telling us what we're doing. We're able to call a function. Our function isn't returning anything, and that's pretty much it. We've now got some code that's inside of the function. Now, what are we doing for a Fibonacci series? We're just setting a and b to be the values of 0 and 1. So a is 0, b is 1. And then we're running a while loop. So, and one thing to note is actually, because we've got this n here, where does n come from? N comes from the top up here inside the brackets, which we never spoke about before, or we mentioned that there might be something there. These are called the arguments, and in our case, if we hover over the function again, it says n is any, and the reason it says it's any is because the function or the interpreter doesn't yet know what might come in. Now we can do type hinting. So this n colon any means any. We can put a colon in here in our function because we want to type hint to the user who's reading our code that we're actually expecting to get back an integer. Now when we hover over this function again, we see that n is of type integer, and it's just a hint to the user. We don't have to do this. We could have just left n as any and checked that it was an integer. But that's quite nice. It's a type hint in the integer, and it doesn't have to be observed. You can actually, Python would allow you to put 2000.1 in. It would throw an error somewhere else, but it might allow you to. It would allow you to do it. So this is just a hint to the user, and that's pretty much it. The only final part really is that this function's returning nothing back. We could again do a hint. We're not going to in this section, but we could do in the next section, return back like an integer, because we're expecting to get an integer back. And then if we hovered over it, we'd be hinting to the user that they'd be getting an integer. And if that was the case, we would want to have like a return statement, return over here, and then 1000 or whatever our answer is, and that's the integer that comes back. We're not doing that. We're just doing it by way of block of code. The final part is we don't actually need to put return statement, so we don't have to return. The block of code is ended at the indentation end. So we are now, if we actually print here, print, we have exited, or we just print outside of the function, outside of the function. So everything in our block of code here is inside of the function, And this line statement on line number 11 is outside of the function, so it's all done by indentation. There's no curly braces, there's no brackets ending it, there's no like we didn't even need a return statement. So visually Python is very aesthetic in terms of its outlook and how functions are created and where they've ended. Now let's just run our little block of code. We're expecting to get Fibonacci numbers up to the value of 2000. And we're expecting to print a whole line of them. This is actually what it's going to do, this body of code. A is going to be at every interval in the while loop up until A gets to the value of n. So A needs to be less than n. Each value of A is going to get its new value of B, and B is going to be the sum of the previous two numbers. So B is going to be A plus the previous B, the previous A plus the previous B. So we can run this piece of code, and then it prints a empty blank line there inside the code. So we got like line by line. So let's just run this function, and here we get so we're outside of the function. That ran first. Nothing in this block is actually run. We've just defined the function. We actually run this block of code. So remember, the Python interpreter runs line by line. So from line number 1, then line number 2, then line number 3, 4, 5. It's defining a function over here on line number 3. And then it's running, like doing all of the definitions of the function, but it's not doing anything of the function. It's not executing any runs yet. It's just storing in memory, as in this is a function. We know a function exists here on line number 3. And then finally on line number 11, it prints outside of the function. And it's only when it gets to line number 14 where the function is actually executed. So that's a function in Python. That's how it runs. And we get whatever is run inside the block of code. We haven't returned anything from the function. But one nice thing that we can do just while we're here in terms of the function, we know that we can use for loops. So we can do for I in range. And let's just set our Fibonacci numbers. So we'll take all Fibonacci sequences from say 100 to 1000 in steps of 100. So we'll get like 10 lines of code that way, and that's our sample of a use case of the range function and the for loop. And we will just do the Fibonacci of I just like that, and we will now run our code. And in fact, I think we can do I don't think we can do a print of Fibonacci. Yeah, we can just do a Fibonacci of I, and let's just run our code. And there we go. We get a whole sequence of incrementing Fibonacci numbers. These are the Fibonacci numbers when we set the value of 100. So they're the Fibonacci numbers up to, but not including 100. These are the ones up to 200, up to 300, and so forth. So they're just our Fibonacci numbers. And that's basically it. So we're able to call our Fibonacci series multiple times. Let's even go up to a really high number, maybe 10,000 in steps of 1,000. Let's just see what happens. Maybe it's limited. Oh, sorry, outside of the function there. Let's put the underscore. I meant to put an underscore in there. Yeah, so we just get incrementally more Fibonacci. We are able to run our function multiple times. So we never had to rewrite this code. We could put it into a simple function, and then we could call our function quite conveniently over here. So that's generally our first use of functions in Python. We're going to get much more elaborate, much more detailed. That's the first use of Python, and we're becoming intermediary coders at this point in time.